function defined in everybody?
Pieces.
Pieces, right? Okay. How are those pieces determined? Just shout it out. How are those pieces determined? Inequalities. And what do the inequalities stand for? Think about when you were in the graphing calculator handbook and you graphed your piecewise function. It was like a line for a while and then it was a parabola, right? It would switch. But how would it know where to switch? Based on the inequalities. So, give me an x. Any x that's less than 0. Go. Negative 1, not 1. Not 6. Negative 6. What else? Negative 2. What else?
Negative 3.79.
Okay, do we get into all the negatives? Alright. Give me a number greater than 0. 1. Greater than or equal to 0. 0. Right? 0.7. 0.9, all of those. So, if we're dealing with piecewise functions, there are legal x's for one piece and legal x's for the other piece. Okay? So, when I go to function notation, help me out real quick. What does this mean? Read it for me. F of negative 1, which? Can someone just raise a hand and explain what am I finding when I'm finding f of negative 1? Tyler.
Replace x with whatever the thingy in parentheses.
Okay, so x is negative 1, and what are you finding at the end? What? The y value. Good. So it's the function value of the function f, or the y value of the function f when x is negative 1. True. Well, when x is negative 1, you guys just told me that only works in one of the pieces up above. And which piece? Top one. Hence why I plugged into the top one. The pen's right there. And then when I simplify PEMDAS, I get 1 plus 1, which is... Okay, we didn't write it yesterday. Some of you might have finished. Most of you didn't. So, here we go. Let's finish off our examples. F of 0, the function value or y value of the function f when x is 0. Do you see why we write this instead of that whole sentence I just blah, blah, blah'd out? Okay. So when x is 0, where is it legal to go?
Where the x was.
Has to be the or equal to, right? So the or equal to 0, it must get plugged into, and I did. 0 minus 1. Right? So I could say, when x is negative 1, y is 2. When x is 0, y is negative 1. And last but not least, when x is 1, has to be plugged into the greater than 0. Plug it in, the y value is 0. Questions on piecewise functions? You might have seen some in last night's homework. Don't ask me a homework question specifically, but ideas. Anybody stuck? In order to plug into a piecewise, you have to test the inequalities, yeah? You have to test the inequalities. You have to test the inequalities and plug into the right piece. And then real quick, just as a reminder, in case you do want to see the graph, how do we put it in our graph again?
You have to
Put parentheses, and separate by, here's the key.
Or. And.
I heard a few. The division sign, right? Now, if it's a sandwiched inequality, you have to separate the two and put an and after you do the divide. Divide, whatever way it goes. Cool. All right, let's keep going. Let's go talk about that difference quotient. I want you guys to write down the formula. Some of you amazing ones were like, Shh, I got the book. The book tells me how to do it. I'll figure it out myself. Awesome. But some of you don't work like that. So for those of you that were able to figure it out from the book, you're going to be an independent learner, and you're going to do okay in college. Those of you that were like, I don't think like that, you're going to have to work harder. You can still make it though. So I'm going to try and help out for today, and we'll just kind of try to wean you off of a teacher telling you everything and get you into working for your education a little bit harder. But it is hard. It's way harder for some than others. And this was a hard formula. It's not an easy one. So even for those of you guys that tried to look and it was still hard, good job. Thank you for trying to look. Just trying to get a little more space down here. There we go. All right, I'll start moving things around. There's a special formula called the difference quotient. You guys had at least like 1 or 2 problems from the homework, right? 2. Thanks. So you had to use this a couple places. Probably right near the end of homework, which is why I was like, still attempt your whole homework, but you might get stuck at the end, and that's okay. We'll figure it out today. as you guys are writing the formula, are you just blindly writing it, or are you somewhat registering in your head what you're writing? For instance, how would you read it? Start with the F. The function of, or F of. If you just said F times, you're going to get way off track. Okay? So even though it looks really funny, and even though there's an X plus H, you have to attach F of. I promise you, never this year am I going to have F and a parenthesis, something inside that means times. I won't do it. It's not fair. Okay? F with a parenthesis is F of. G with a parenthesis is G of. Okay? So, F of X plus H minus, keep reading. All over. When honors went through this a couple days ago, some of them were like, I was just confused because they didn't really tell us what to do. And I mean, they kind of do and they kind of don't. The problem just says find it. And you're like, But when you read it, hopefully you realize what they're asking you to find. So, if I was to take everything away and just ask, because you need to plug in F of X plus H. That's a part of the formula that needs to get put in there for this particular F of X. If I just wanted this, function notation, what would you guys do? Plug it in, but where? Inside each of the parentheses that you need to put. That's what I'm trying to train you guys to think, whether or not you actually say it out loud. Plug it in. And remember, each of these X's, kind of like yesterday with function notation, if I can go find it, the one with boxes, remember, wherever there's an X, it's kind of like, if you guys saw this on the computer screen, the X's were gone, and they were like a little box. There was a box there, box there, box there. Wouldn't you think you had to put something in? Right? It's asking for something. Same thing here. So when an X is here, we put into the X spot X's. But when something a little bit harder is in the parentheses, whatever, we copy it and we copy it. So let's come back to our example. It's something even a little harder still. But what is it? Whatever they tell us. So X plus H goes inside to replace what was there before. Think of it as a box that needs to be filled in. So you have X plus H. Nice. Okay. And hopefully, if you can understand this, you'll see why in the next step, when I go to actually put all the pieces together, why the first part looks just like what I just did. Okay? So, here, let's take our F of X plus H. Here's the formula. It literally is just a formula. Special formula called the difference quotient, but it is just a formula. So I'm going to go ahead and plug in. Now some of you are like, wait a minute, I can do stuff. If you want to do stuff now, that's totally fine. If you want to wait and try to do it all together, that's fine as well in the sense of, in the context of the problem. What have I done so far? Copied F of X plus H. Now there's 3 pieces to this formula. Technically 4 if you count the minus sign. So I have one piece done. Ugh, it's long, but it's fine. Minus, what's my next piece to plug in? What's bad if I just do this, which a lot of you do? Because I'm subtracting the whole thing, which means all of the signs need to flip, and if you don't put parentheses, you're not going to remember. Maybe you'll remember once or twice, you won't remember every time. Remember, I've graded a lot of math papers in my teaching career. I know what mistakes are usually made. And then, H. Is there an F of anywhere? Well then, that doesn't matter. Just put an H. Okay. Box it, you're done. Just kidding. We've set it up. Now, what's kind of the understood direction in almost all of math? Plug it in, do this, do that, and then simplify. All right, cool kids. How do we simplify this puppy?
Foil.
Foil! Nicely done. Foil what part? Only the first part. Because remember, x plus h squared is x plus h times x plus h which ends up with, I know, I'm doing this fast. I'm using the trick of a perfect square trinomial. What happens when you have a binomial squared? But wouldn't it also work if you had done first x squared, outer 1xh or hx, doesn't matter, whichever way you write it. One of those plus another one of those, that's two of those, plus h squared is last. What do you think? And if you don't want to admit that someone in Precalc could do it, oh, they certainly can. What do you think is one of the most common mistakes with this? Squared, squared. Yay, it's easy, it's fast and done. But is it right? You leave out a whole piece. Okay, careful, careful, careful. Hence why I say, if you square, which those of you over there might not be able to see, if you were to say that this is this, a poor little puppy dies. Because you did not multiply a puppy, right? That is not true. What's the proper way to do this? FOIL. Some of you need to write it to do it, and that's totally fine. Some of you could just do it in your head and get to the same answer. I don't care as long as you're getting it right. Okay? Please don't kill puppies. It's just sad. If you don't like puppies, too bad. Don't lose points. Okay, so some of you are like, I don't like cats. I'll just do that one. No. What do I do with the minus of the next part? And what I like to do is distribute all at once so I don't forget anything. Some of you like to do it in your head. That's fine. Some of you just forget it and then you get it wrong. Don't do that. Minus x squared plus 4x minus 7 all over h. Simplify. Combine like terms. Like. Oh, where is my 7? Gosh. Look at these. Complicated problems, things just go missing. There he is. I know. Teachers are supposed to be perfect. Just kidding. We're supposed to model how to strive for excellence despite being imperfect. All messing up grades. Come back. X squared's gone. 7's gone. 4x's. He's still there. Okay. Who was blindly following? My blind followers, don't do that. Was the plus 7 enough to fix everything? Okay. Who is this?
That's the X.
Nice. Where did I skip? Oh, what about these guys?
Oh,
Okay.
thank you.
Quick word to the wise, if you blindly follow. Doesn't always work out so good. Coming back. Life lesson. Math lesson and life lesson all in one. Now we're good. Double check me. Looking? Tracking? Thinking? Not just following? Alright. Now it cancels. Huh. Wow, lots of stuff left. What's still there? 2hx plus h squared minus 4h. I guess I'm done. No, I'm not. Psh, I see that h. He's gone. Done.
No.
What'd I kill? Can I just see something that matches up and just randomly cross them out without thinking?
No, if you believe them.
What is the only legal way to simplify that h out?
Foil.
Oh, almost. Factor. Factor out what? The common factor, which is h. I get 2x plus h minus 4. Now I can cancel that, right? Cancel that. It's not puppy. Kitten. Whatever. I can reduce it legally. So I can say, boom, boom, 2x plus h minus 4. Dun, 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 dun. Thank you. Is it complicated? Yes. Very much so. Is it possible with algebra and careful work and simplifying. Yeah. Yeah, you just have to be careful. Any quick questions before we go on difference quotient? How many of you guys are like, that would have been nice for homework? How many of you guys are like, I think I can do those last two, at least try them now. The other half, you already did it because you mastered it last night? Or you're going to come ask me after school when you're stuck?
The latter.
We'll try. Alright, here we go. Homework number 4, section 1.4. Let's go ahead and go check those even IC. You get a better view. Section 1, section 2, section 3. Hold on. I have all my evens. Guys, try one more time. Alright, hold on, wait. If we are going to check our evens, what do we need to see? We need color pen. Not black, not gray, not light tan, not a highlighter. Alright, there he is. Double check your assignment with mine. Ready? Same assignment, ending at 85? Oh, I'm at 1.2? It went back somehow. Don't worry. There you go. Oh, Stanton. All better. Ending with 81. That sound better? Yeah. Number 2, independent comes first and then dependent. Number 4, the difference quotient, which you might have not quite known. Number 10, let me highlight or circle the important stuff. Not a function. Letter B, does represent a function, so is a function. Letter C, not a function. And letter D, does represent a function. So no, yes, no, yes. Is it okay? Remember, no shame in having written down the wrong one. We just want to figure it out for you and for us. All right, so no, yes, no, yes. Number next one. Nope. Why not though? Remember, x equals a tick mark on the x-axis goes vertically. Vertical line test. It's fine, it's fine, it's fine. It infinitely fails. Well, that doesn't work. Remember, it can't hit more than one point on any one vertical line. And this one hits all the points at x equals 1. That's a no. That's a no. Remember, next one? They're all spread out because I made them bigger. Let me give you a second. You have to fill in a table with given x values, figuring out what piece you should plug into. Give you a little bit of time to see if you checked your table. Obviously, you didn't necessarily have to show all this work. Just make sure you were plugging into the correct piece and simplifying properly. Yeah, David. For the first two? Okay. Technically, if you can kind of tell the pattern, the first two plug into the first piece, the bottom 3 plug into the bottom piece. That's not something to memorize, just something to see. Now let's look and see what those x values were that were being plugged in. So remember, f of, we're plugging in x is 1, but we have to ask ourselves the question, in this piecewise, x equals 1 belongs where? Is he less than 3 or is he greater than 3? 1 is less So then, this is the legal piece to plug it in. As opposed to f of 3, x equals 3. Where does he belong? 3, but not or equal to. 3 or equal to. He belongs in this place. And anything higher, 4, 5, 10, 100, a million, would plug into this. Anything lower than 3, 2, 1, 0, negative 1, all of those should be plugged into. Does that make more sense? It's just something to kind of get used to with piecewise. It's like, wait, what? Test the x and ask which one, if I were to plug in the given x value, go back. I did go back. Now what? This is weird. Oh my goodness. I'm gonna move forward. Which one would make a true statement? 1 less than 3, true, plug it in. 1 greater than or equal to 3, false, don't plug it in. Go to the next one. 56. Oh my goodness, look at that sentence. I bet none of you wrote it. Unless you were doing calc chat a lot. For 55 and then used it. No, okay, that's you thinking creatively. What's another way of writing this whole huge sentence? Not all real numbers. All real numbers except Ricky.
For those, do you have to put the D colon? Is it like
If the question is asking what is the domain, you could just box x not equal to. But if we're like analyzing a function and we have to label domain, range, and this and that, please put it. Number 66. Is he rough? Adam. Oh, you didn't have 66? Sweet. That's one I left for honors. Nice. That one was really rough. Let's get rid of it. 68. You're on that one? It depends on your brain. Visual people, it might not have been bad. Non-visual people were like, I don't know. You were supposed to, and you could have graphed in your calculator, put in a square or rectangle? Rectangle, right? Into this function. Who graphed this function? What did he look like?
semicircle.
He looked like an upward or a downwards parabola, but he actually, if we were to square both sides, he was a circle, but only the top half because it was only the positive or principal square root. So it technically was a semicircle. Were you supposed to fit inside him? Rectangle, right? Did they give you a picture of this one? They did? I can fit this rectangle in. I'm not sure he has a very big area. I can fit this rectangle in. I'm not sure he has a very big area. The biggest area is probably something like this. But here's the dilemma. We're not allowed to draw a million different rectangles and figure out which one looks the biggest. That wasn't the point. The point was to think for any of these rectangles, they all have to hit the curve somewhere. How do I talk about area of a rectangle? Length times width. But how do I talk about the length of each of these in terms of x and y? Kind of tick marks. Except if I'm not allowed to actually make it a number, I have to choose one. Keep it general, pretend there are no tick marks and say, how could I use x, which is the horizontal distance, to describe the length? If this is x, what's the whole thing? If this distance is x, then this distance is x2. Hence why the length, remember x is how far over you go. So for this rectangle, x is half the length, so double it. That's the whole length. And then what could I talk about for the height? Y is how far up you go. So that's why they got 2x plus y, or sorry, 2x times y, length times width, as our area formula. But the problem is we can't do much with that. And they said find area as a function of who alone? Look at it. So who didn't belong? So we had to go looking and say, there's something they told us that was a clue about how to substitute out the y for something in terms of x. Plug it in, done. Now, to be honest, this is something even calculus kids still struggle with. I just gave you a peek at it because it had to do with understanding x is over, y is up, and how can we apply that to like some numeric rectangle. We had is that our last even though? I think that was our last even. Real quick, we're not going to be able to spend lots of time. But I haven't done this in a couple days. In section 1.4, I think is a pretty hard homework. What do you guys think? Medium. Okay. Were there any particular odds? And I have my book in front of me. We can look at them real quick. Any ones that you're like, I just don't know.
81.
81. He was rough. Anything else? He's the worst? 77. It makes sense. We don't like the last one. Sometimes they're hard.
That's the
Okay. 77 is difference quotient. I might not simplify, but I'll set it up. And then 81 is a difference quotient too. But a little bit weird. All right, let's peek at those real fast. If you guys have your homework, let's just go ahead and still keep grading 77 and 81, all right? I'm going to go here. Okay. You guys have 77 written down, right? Sweet. We're trying to find a difference quotient. That looks a little funny, doesn't it? What's my f of x?
X squared minus x plus 1.
Minus 1x plus 1? Okay. What am I trying to find? F of
2 plus h minus f 2 over h.
like that?
H can equal 0.
Alright, kiddos. As you read this, and as Ricky was reading it, and as that's not what I want. It's f of, not f times, right? So, how do I find f of 2 plus h? Figure out where to plug it in. Yeah? So then I end up with, start reading it off. Just the first part. How do I do them? No, it's actually f of means go put it in f. So you go put it in f. And what happens? 2 plus h, quantity squared, minus, put the 2 plus h in, plus 1. That's this part. If you need to, like me, you might get lost in your work. Make sure you got everything. Then what? And what's f of 2? How do I do that? Right. Then I can do 2 squared. Why did I put all these parentheses over here, but I didn't put any right there? It's just a single 2, right? So I can just throw them in real quick and it'll work out. But as soon as I have a binomial or bigger, everything gets messed up. Now for right now, because I know you guys can check out the answer, just tell me the directions. What would you do? Simplify. Simplify by FOILing. Do it legally. Then by distributing, making sure you have everything, unlike me, and put it all together. Cool? And hopefully an h will come out, an h will cancel, and you'll have one little expression with numbers and x, I think an x term and then an h. Now, number 81 is just a little different in what they give you, but similar idea. Ricky, that was yours, right? Number 80. Okay, what was the g? It was g of x, right? What did he equal?
1 over x squared.
Woo! Look at that. It's okay, we got this. What did they want us to plug into? It was
G of x minus g of 3 over x minus 3. And x can equal 3.
and x can't equal 3. Help me out. When I'm finding g of x, well, hold on. Who is g of x? Minus, okay, got him. Who's g of 3? Plug in 3. 3 squared is 9. And then, oh, that's pretty. Box him. Simplify. Okay, I'm just going to show you a trick. We'll develop it throughout this year. Some of you are like, oh my goodness, are you kidding me? Common denominators, put him over 1, multiply by the reciprocal, it's going to take forever. My trick, it actually came from watching my math teacher teach in Uganda. It was kind of cool. A few years ago on a school mission trip. Was to take, or is to take, all the denominators I see within each piece of my fraction. Technically, who is he over? This one. What I do on top, I have to do on bottom. And look at what happens. When I bring him in, what happens to that if I just multiply? What happens to the x squared? It cancels, and what's left? The x squareds cancel. 9 is left. Okay. When I distribute again, what cancels? Who's left? Nice. And on bottom, now you can distribute, or I kind of like to leave it, if I can, leave it factored, because simplifying is kind of factoring, right? Well, that looks a bit better than it did. No more complex fractions. And some of you are like, I think I can keep going, and you can. 3 minus x, 3 plus x. Maybe something kind of cancels. But once again, I know you have the back of the book and how chat. So hopefully I got you started on the right path. Let's go ahead and notes out section 1.5. I started today. Maybe not finished. But we better start. If we can get through interval notation, I'll be happy. I think we can. Unless I say otherwise, if you guys see a graph like this in your notes, some of you would take a long time to write it and draw it and make it perfect. And I appreciate that. That means you have attention to detail, and that's a good thing. But unless I say otherwise, you can just do a quick sketch, especially when they aren't giving us a lot of particulars. Yeah, there are tick marks, but it doesn't really matter. The point of the graph is we have a function. Let's remember, whenever we have main point. Whenever we have a point on that function, it's just kind of reminding us f of x values are technically y values. And we can get numbers for both of these. If we have a number for x, we can plug into f to get a number for y. And x is how far over you go, whether to the right positively or to the left negatively. Y is how far up we go, whether up positively or down negatively. That's just a quick reminder, and this is kind of from, if you think about it, that weird rectangle in a semicircle problem, where I know you guys know how to graph an x and y. Unless it's a bad day, then sometimes it goes wrong. But thinking about how x is an actual distance horizontally and y is an actual distance vertically to a point, maybe we haven't thought a lot about before. Do a quick squiggle and then be like, hey, point. Label x as how far over. F of x, which is like the y, how far up. Meaning of the point. Which hopefully helps some of you that are still struggling with function notation. When we have an x like 1, f of 1 is just equal to the y value. That's all we're talking about. Technically, this is kind of review, sort of, but you're going to have to think about it, use it a few different ways in section 1.5. The next page, I think for almost all of you, is brand new.
Yay.
Okay, ready? It's not brand new in that it's a brand new idea. It's brand new in that it's a brand new notation for something you've been doing for quite a while. It's a brand new notation for inequalities. It's a brand new notation for inequalities. Quick reminder, I talked through with a kid yesterday. He's an honors Precalc. He's kind of like, you know what, for my learning style, I think you have a point when you say, maybe it's better for me just to listen in class and take notes at home. Just be thinking through, guys, with the notes online and the videos online. You can take more time on each lesson. You don't have to feel stressed in class to write everything down, to hear it all the first time, understand it all the first time. That's not the point. Sometimes it takes longer than the first time to figure something out, especially with math. But if I do see something in class, like you not following along or not taking notes, I probably will talk to you just to double check that everything's okay. But if you are doing it at home, I don't mind, okay? So please realize if I ever talk to you about something or others, it's just because I care and I'm just trying to make sure that we're doing all right and you're doing all right. Because I know sometimes it's hard to come into a new teacher and ask questions and make sure everything's okay. Please, please, please. Know that I'm here for you. If I can help, please let me know. On anything, current, past, future, sure, why not? Down in the examples below, I'm going to go ahead and write how the first one looks in this new notation. And I want you guys to think about what you've written about parentheses and about brackets to see if it possibly makes sense. Think about it. This is a new notation. It means ultimately the exact same thing as the old notation. It's just more applicable, more useful in higher maths, proving. Intervals are great. Unless I say interval notation, I probably don't mind you writing with inequalities. So that's kind of the elementary way. This is kind of the grown-up way. In terms of, like, as far as math is concerned, like mathematicians would say, okay? But why a parenthesis? Put it together. Let's see if you guys can get it without me really teaching anything. Caleb.
Because there's no underline. It's just
No underline, which means not including or not equal to. And what does a parenthesis denote? Limited by but not equal to. Is -2 a boundary? Yes. But can you hit -2? No. Okay. Think like basketball in the sense of the out of bounds. Are they boundaries? Yes. Can you be on them and everything's okay? No, you're out. Okay. Same thing here. How about over here? The 5, Y bracket, or equal to, and a bracket shows equal to. Now question, what if I was to put, let me do a different color. What if I was to put an or equal to there as well? What would need to change? That would need to be closed, right? And what if similarly I was to take away the or equal to on the 5, what would need to change? Now wait, look at this. Why could this notation, as you're getting used to it, get confusing? Looks like a point, which would have an x value and a y value, but wait, what is this talking about? All x's from -2 through 5. So is this going to take a little bit of getting used to? But if you see like a bracket, you're like, oh, it's good, it's something new. Oh, that's right, intervals. Just be aware. 2 parentheses with 2 numbers and a comma in between does not always mean an ordered pair. Now, can someone kind of just describe what word could we replace the comma with and it still makes sense? Through. That's a good one. Or maybe 2. Like -2 to 5 or -2 through 5. Just think of the comma as that. Now, let's think about letter B. So interval notation, commas and brackets. Sorry, did I say comma? Parentheses and brackets. Commas to separate the 2 endpoints. And then the lower on the left and the higher on the right. So the only other weird thing is a little e. Did I show you guys that before?
Yeah.
I think so. It means is an element of, is within, all x values in between. different ways of saying, but is an element of is the technical way. Let me go to the next one. If x is greater than or equal to 3, question, how low can x go? Or what's x bounded by on the low side? 3. Bracket or parenthesis? Bracket, because it's or equal to. What should go next? Comma, because we're talking about a whole set of numbers. What's going to mark the end of x greater than? Positive infinity. Now, here's a good question to think about. It's a little mind-boggling. Parenthesis or bracket? Here's the question. Can you equal an idea? Equal a number. Infinity is not a number. Infinity encapsulates the idea of get bigger and bigger and bigger and bigger and bigger and bigger and keep going. So it's going to have to be. You can't end infinity. So it's going to be open. The last one, what do you guys think? How far down can you go? Negative infinity. How far up can you go? Wait, was that right? What should I have at 1? You guys might be able to start homework 5. It's using the new notation, but we definitely have more to do tomorrow. Alright guys, I'll see you later. Questions, come find me, please, please. No, you're totally fine. After school is good.
It's on an ion.
I should have done better.
It's literally an ion. That is the easiest.
Nice seating charts. Got it all?